Yes, men då lämnar vi över till Steve Carr från Wittra.
Thank you. I apologize first of all for presenting in English. I'm standing in for a colleague today. So firstly, can you see my screen?
Yes.
Perfect, thank you. So Wittra is an IoT organization which really looks to answer the question, where is my stuff and what is it doing, especially when it comes down to areas such as logistics and also to tracking. It seems on the face of the question a relatively straightforward question to answer. However, there are a number of complexities associated to tracking devices across various radio types of technologies. We're all familiar with things such as GPS, but GPS doesn't work both indoors and outdoors. We're familiar with Wi-Fi, and Wi-Fi will work indoors and outdoors. Wittra looked to solve the problem where they could track products both indoors and outdoors, and also as we move forward into long range. The market's exceptionally large, with around $1.3 trillion of investment going into it by 2025, and around 75 to 80 billion devices being connected. One of the things that we've been looking at is really how do we drive a connected environment that sits alongside other back-end solutions and back-end systems that's able to integrate and collaborate, is secure and connect seamlessly. Today, many projects actually fail because they don't actually cover these core technologies within the scope of the programs that they're operating. So what Wittra have tried to do is really overcome many of these IoT obstacles at the front end to really deliver solutions that work with the customer and work seamlessly with the customer's end systems. Digital transformation, as we've all seen, has really begun to rise and accelerate during the COVID-19 pandemic. And the hunger for the IoT deployment remains high. But as I mentioned before, a number actually as high as 75% of traditional IoT proof of concepts fail. The term proof of concept is commonly used within IoT, but within Wittra, that term is actually banned. Wittra only focus on proof of value. We try to actually move beyond proof of concept and make the integration as seamless and as easy as we can. There are 6 key primary problems and obstacles to IoT deployment, from organizational and cultural change, from the time it takes to deploy a project, down to the skills not necessarily being available inside the organization. And as previously mentioned, security, interconnectivity, and actually scalability also become challenges. The Wittra advantage is to really remove all of those challenges and give organizations the ability to track, locate, and trace their assets from day one. Driving straight to proof of value, you're able to set up a Wittra network kit within hours. Normally and traditionally, proof of concepts have taken kind of months, in some cases, if not years, to kind of 18 months to 2 years. The Wittra network has everything in place that you would need. It has the hardware, the gateway, the cloud services, and the software associated to any IoT project. And Wittra provides a high level of security through a TPM chip for authentication, meaning that encryption and authentication are actually taken care of immediately on the devices. In fact, we add a TPM authentication chip on every device, from the tag that will sit on the asset through to the mesh router to help expand the mesh network, all the way up to the gateway that's going to communicate the data back to the organization. We connect seamlessly and reliably, and as you see as I walk through the presentation, we actually operate within harsh environments. If you look at many types of locations where you might want to deploy logistics tracking, such as a warehousing environment, you'll find that there is a lot of metal, there's a lot of interference, which actually does have an impact in terms of the signal impacts. So Wittra have overcome these. As I mentioned before, we can scale devices, you can add devices into the system, and actually everything that's done within the Wittra organization comes with a predictability in terms of cost and the ROI that's going to be enjoyed by the customer, with all devices being software upgradable, which really does help in terms of costs and cost advantages over competition. So what do we really do? Well, we are actually redefining the IoT landscape. We're taking clients straight to proof of value. Our products are pre-integrated, pre-tested, and pre-secure, so there's no need to actually go out and get further certifications. You can communicate, control, and collect information around your assets, even in the toughest environments. We're trying to bring IoT to the mass market. We're trying to simplify, accelerate, and drive a predefined ROI. Make sure that you focus on proof of value, and we do that through high collaboration. So we actually remove some of the early fragmentation that takes place within an IoT ecosystem in order to ensure that the devices are delivered, deployed, and actually operate immediately from the box. So what is the problem as we see it? Well, assets aren't just devices. Assets can be people, objects, and devices. These change locations. They operate in different environments. They operate in environments that change. You know, the challenges of maintaining network connectivity is exceptionally difficult. Wittra have overcome that challenge, and you're able to sense, locate, and connect all of their assets within these environments. So if you can consider a mining environment, a warehousing environment, a marine environment, a construction type environment, all of these will be challenging for normal connectivity type solutions, or would be very costly to deploy a network. Wittra has overcome all of these solutions with the Wittra network kit. So let's take a look at the technology that we're looking at. Quite a detailed graph, and actually if you go to the Wittra website, you'll actually see the spidergram, and you can actually just mouse over each of the areas such as range, penetration, capacity, and you'll get an explanation as to how we break these down and how we define these terms. But in essence, what you can see here is how we compare to other technologies within the marketplace. So looking at GPS, Wi-Fi, some of the 5G deployments in terms of NB-IoT and LTE-M, Bluetooth, LoRaWAN and Sigfox, some of the LPWAN standards that have been around a number of years. And then, of course, you have the Wittra technology. Now, you can see from the graph here that Wittra doesn't necessarily have the longest of range, but we talk about having the best penetration capacity, which is really important when you're trying to track and locate assets and you're really trying to locate within a defined area. In terms of location, if we're using RSSI, which is a signal strength indicator, and depending on how your deployment is deployed or how your mesh routers are deployed, we can track devices down to a meter. If we use our time of flight technology, it's around 5 to 10 meters, depending again on the environment. But as you look around the spidergram, you can see that Wittra on the whole outperforms and matches the competition, as you can see. So we actually do believe that after 8 years of developing and designing a solution, we have a best-in-class solution for the majority of IoT applications. I mentioned before, we don't necessarily have the longest range, and we'll touch on this in some detail as we move forward. But as you can go and look on the right-hand side of this particular graph, particular slide, you'll see Wittra plus Myot. Myot is a new LPWAN standard, and this LPWAN standard will replace LoRa and Sigfox. That's our belief. LoRa and Sigfox will still exist, but we believe that Myot gives much more strength, is much more commercially reliable, and will actually overtake both Sigfox and LoRa as we move forward into the next 2 or 3 years. So Myot being a new standard in LPWAN overcomes two of the major problems that the technologies have seen. One is unreliable data delivery, and the other one is limited data capacity. Both LoRa and Sigfox, although great technologies as they move forward, can only deliver 90% of their data packets on a reliable basis. Myot can deliver 100% of the data, 100% of the time. Additionally, Myot will actually allow one gateway to talk to 100,000 end sensors, end nodes, and will deliver 1.5 million messages a day as you move forward. So it really does remove all of the challenges that the market had seen previously with both Sigfox and LoRa. So looking at a bit of a chart here, you can see where Wittra compares to the other technologies. And in the main, we are either best or better than the other technologies that are out there. And we believe that Wittra has and will become recognized not just as a brand, but almost as a pseudo standard. The standards that it has, it uses 6LoWPAN, so it's a sub-gig standard, and going forward also Myot. If we look at our products so that you can understand the products that we have, if you start over on the top left, the gateway is easy to deploy. It's an Ethernet plug-in gateway. It does have Wi-Fi available through the the Linux board that's on it. We don't always recommend using Wi-Fi on the basis that Wi-Fi can inherently be unreliable. So we would suggest either a cellular backhaul or using the connectivity that we have in there moving forward. So, Ethernet and cellular are definitely the way to go in terms of the gateway, but Wi-Fi is available on there. Our tags contain a number of sensors, such as an accelerometer, a gyroscope, a magnetometer, so we can actually measure movement, orientation of devices to actually track and locate where those devices are. It uses a sub-gig radio. By using a sub-gig radio, it can penetrate very, very harsh environments. It can move through concrete 2 or 3 stories up. We can do an XY axis location in terms of how we position. And we're able to expand that out by using the mesh routers. And the mesh routers, if you deploy a mesh router every 200 to 300 yards, you can just keep expanding the mesh to whatever size and whatever perimeter that you actually define that you actually need. In fact, if you look at our gateway and you look at a single tag deployment, deployed with a gateway being raised by a couple of meters in terms of line of sight, you can get up to half a kilometer position straight to one sensor tag. Now, clearly for speed of data and more reliability, and because most deployments aren't on pure line of sight, we recommend a couple of 100 meters, but you can continue to add routers into your meshwork to expand your meshwork to the required size that you actually need. In addition to our standard sensor tag, we also have a clip-on sensor. This clip-on sensor actually means that you can design, develop, and have built some additional sensors such as gas detention or more. The one we have there is accuracy, humidity on that particular device. But if you wanted to measure such as carbon monoxide, you could develop and clip on a sensor for carbon monoxide in that example. So it's exceptionally expandable in terms of the approach that we take. It makes it very, very easy for somebody to deploy. And without the need to be a technology expert in terms of IoT, this really is child's play in terms of taking a kit, deploying it within an environment and beginning to see location data and data associated to the devices that you've actually tagged. Our kit comes ready to go with a cloud API, so you can hook straight in and you can feed that straight into a back-end solution. And we also include all of the accessories that you would ever need in order to actually deploy, from the antenna to go into the gateway down to straps to actually connect some of the tags onto things such as pallets or other assets that you actually may have, along with the various power supplies to charge. From a battery life perspective, a typical sensor tag transmitting data, let's say, I don't know, every 10 minutes, will last you up to 9 months. If you use an expanded battery pack, which comes within the Wittra portfolio, that will actually go out to probably 3 times that, so 2 maybe to 2.5 years in terms of battery capacity as you actually move forward. All of these devices come as a rechargeable solution, so you can just plug in a micro USB and the devices can actually be charged for future use. Looking at our complete solution, you can see here from a Wittra hardware perspective, you have the asset tags and the mesh routers. So the asset tag will connect and talk to any one of those mesh routers. In fact, because we use the mesh technology, and I mentioned simplicity in terms of deployment, our mesh is self-healing and self-forming. So it deploys and it figures out the best connectivity route for it to actually take, which makes it very, very simple to deploy. And our development platform also gives you a measurement in terms of signal strength between the various devices, so you know how to position your devices in the best possible way. Again, making it exceptionally simple to deploy. We currently have our API cloud hosted in Google. It doesn't need to be Google. We use API hooks to actually go forward. And our development platform, which is very, very intuitive, allows you to commission and measure and look at your devices. We actually do have a map on there. Our backend platform isn't designed to be a commercial platform. It's designed really as an enablement platform for customers, and also, as I mentioned before, a commissioning platform to make things as easy as we possibly can for people to look and see devices. Just to give you a bit of a visualization on the Wittra difference, if you look at these two construction sites, and you look firstly onto the left-hand side, which is the Wi-Fi Bluetooth deployment, all of those red dots give you an indication of the hardware deployment needed in order to track, locate, and measure assets in that particular area. So it requires an exceptionally dense network to provide accurate positioning. It's expensive, and it really does disturb site operations in terms of deployment, as well as being clearly time consuming. And you still have the interference that you would get from moving assets within inside the environments, similar to other radio type technologies. If you look on the right hand side of this particular chart, you'll notice the Wittra solution. The Wittra approach is very, very different. Because we use a sub-gigahertz radio in our devices, less hardware is required because it's got better penetration and it can operate in significantly harsher environments. It can operate both indoors and outdoors. So you know, Wi-Fi and Bluetooth are typically indoor type technologies, or very short range type technologies in the case of Bluetooth. But with the Wittra technology, it's indoors and an outdoor type deployment. It's less hardware, so therefore at lower cost. There's less disturbance because there's less hardware. It's very, very quick to deploy and gives you significantly better coverage. Now, these diagrams aren't an exact like for like, but it does give a really true kind of visualization of the difference that you would actually have. So a Wittra deployment can actually cover multiple floors on one deployment, give you an accuracy reading of around 1 meter using RSSI, depending on your position of your routers, and a reading of between 5 and 10 meters on time of flight, which means you can actually spread your router significantly further apart if you decide to use time of flight. The core technology is based around 6LoWPAN, which has been around a number of years, but I guess it hasn't been regarded as one of the sexiest technologies. It's a technology that's been used in labs and in institutions in terms of developing radio mesh solutions. However, today, this is really gaining some significant traction. It's an IP-based system, making it very easy to integrate with other systems and other back-end solutions. So people are very familiar with IP-based solutions. It's open standard. So again, everything we do, we try to make open standard to make the integration as easy as we possibly can. It gives exceptionally good range and good penetration of structures. And we use what we term frequency hopping. So we're able to hop across many different channels, which really does mean that your data delivery in terms of locating where an asset is, as an example, is exceptionally robust, even in the harshest of environments. Our positioning technology, and we have a number of patents in terms of our time of flight positioning technology, is pretty unique in terms of what we do. Positioning down to 1 meter using RSSI is very, very market edge. It's right at the leading edge of what can be achieved. You know, other people will talk about positioning down to probably sub 1 meter, maybe to 30 centimeters, using things such as ultra wideband type technologies. But again, the deployment and the amount of devices you can have to a gateway are exceptionally limited, so it's really not ideal for a commercial deployment. Whereas Wittra has this unique positioning technology, making the devices exceptionally good for tracking, for pallet tracking, for asset tracking, for equipment tracking, whether it's static, whether it's moving, whether it's indoors or whether it's outdoors. And we've really solved what was regarded as the impossible by getting accurate positioning over narrowband technologies. Mentioned before, again, accurate long range, and really does move through complex structures. Additionally, we have future proofing in terms of our solution. We use software upgradable processors known as software defined radios, which in effect means that you can actually position your devices, you can forget them, and if you wanted to change your infrastructure, you're able to do that by using over-the-air upgrades. To give you a comparable, if you're trying to do this with a Bluetooth-based technology, you would likely have to go and replace all of your end tags, all of your end nodes physically, because they're not upgradable as you move forward, where the Wittra solution is upgradable. That means that the return on investment and the total cost of ownership equations actually change dramatically and benefit the customer immensely. So if we look at 6LoWPAN and LPWAN, combining two technologies, you know, if we look at the LPWAN market, it's got 231 million connections, and they're beginning to look to move into the location of asset type space. Typically, it's on a peer-to-peer basis, but there has been 110% increase compared to 2018, and it's still growing fast. Mentioned before, though, that the two out there, the two leaders out there, in terms of LoRa and in terms of Sigfox can only guarantee 90% delivery throughput, which isn't good if you're looking for a particular piece of equipment or a particular pallet of equipment. And they don't always track effectively both indoors and outdoors. And we've already mentioned how Wittra do that. So graphically, when you're looking at positioning and the deployment challenges that you'll see, if you use LoRa, Sigfox, or a combination, as I showed you before, of BLE or Wi-Fi, and you wanted to track something inside or outside a building, you'd have to have several hundreds of beacons, and the coverage still wouldn't be good enough to cover the outside of the building. So not really a very practical approach to overall positioning. If you looked at the current technology that we have within Wittra without the addition of Myloc, again, with 50 routers, you can cover an entire area. You just work around the perimeter that you're looking to cover, and you can actually have both sensor data and positioning within those areas using both RSSI or time of flight as we move forward. So again, a significantly better area of deployment and actually works in a much more practical manner when you're trying to locate and track assets. But if you look at an optimal solution, which is adding Myloc and Wittra, and you add that into a single type solution, not only would you get the benefits that you see in the slide I'm showing again now, which is by creating a perimeter, you're able to really get a solid, strong mesh environment, even in the toughest environments. By actually adding Myloc into that, you're able to get LPWAN technology, which means you could track devices 15, 20 kilometers away, and moving from location to location, or from depot to depot, or from building site to building site. So a significant benefit as we actually move forward. We'll actually be launching a combination of Myloc and Wittra later this year with an automatic handoff between two technologies. Again, this is something that's not been explored or seen within the IoT space as we move forward. So why Wittra? Well, we're fast, simple, affordable, and reliable, as well as being scalable in terms of what we're doing. We move straight to proof of concept. So if you want to track your assets, you can do that pretty much immediately from deploying a network kit. The devices are pre-integrated, pre-trusted, and pre-secured. So you have no need to undertake a proof of concept. You're moving straight to proof of value. It eliminates costly multiple engagements with other third parties, and it gives predictability in terms of your defined ROI. And we use a true mesh, true sub-gigahertz solution, which gives you that reliability no matter the environment. And if there are any radio black spots, all you need to do is add another mesh router in, and that black spot's gone. So it really is total coverage and total visibility as you move forward. You know, we are really finding the IoT landscape. The technology we have got does take you straight to proof of value, and we do believe that the type of deployment we got is unsurpassed within the marketplace today. So there are a number of challenges as we've gone through in terms of total asset visibility, in terms of location, movement detection, position orientation. All of these actually for other technologies cause a degree of challenge and a degree of concern, but not for Wittra. This is built into the DNA of the tags that we have. And you can even, through your own software or backend solutions, build in event triggers as well. So fed from the API. We stream the data through the API, as I've mentioned before, to the API hook, and then onto any backend solution that you would require. And we do work with some of the market-leading platform providers, such as Software AG, Cumulocity, Cogitel, Telio. So we have a number of ready-baked, ready-made platforms or providers that we could align people to in order to make that happen. It is very much a multi-market type environment, from healthcare, manufacturing, facilities, maritime, logistics, construction. All of the others are on there. We have long-range transmission. It's easy to extend to actually expand, as I mentioned before. We can actually get 0.5 kilometer from a gateway to a node using line of sight, as long as we've actually got the gateway orientated correctly. Seamless transition between environments, so it's not a matter of you losing a signal when you move indoors to outdoors. It's completely seamless, and we have high data transmission and capabilities, and I mentioned before the frequency hopping. Just a few of the challenges that we've solved, in healthcare, manufacturing, construction, logistics, any large area, any misplaced assets, misuse, maintenance alerts, heat maps, usage tracking. All of these things form part of the DNA that we have with inside Wittra. Some of the benefits, well, we improve productivity. We can give you a map of the resources and the assets within that location. We can automate and give you equipment utilization reporting. You can generate heat maps based on resource monitoring within your system, automated data flow for workflow planning, and you get sustainability, predictive maintenance on devices, reduction in theft. You don't get lost devices. It reduces the carbon footprint because of that predictability and maintenance, and it will generate cost savings as you actually move forward. A network kit is on the market and is already available. I mentioned before, it's easy to configure, install, and support. It's very, very short time to market. You can deploy a network kit within hours, and you could deploy a complete network environment inside days without any problem at all. When you use a network kit, that kit can stay deployed and can actually form part of the final network that you've actually got in play. And we are future-proof with expandability and with click-on sensors and also remote software upgrades, as I mentioned, that occur over the air. So you can add on more hardware to the kits. You can have multiple sites. The sensors will pick up and will be located between the sites because they are IP addressed. We have security in everything that we do. And as I mentioned before, all the devices come pre-certified. So we're CE, FCC approved, ISED approved. So you don't have to worry about any of the regulatory compliances. All of those things are actually now taken care of. We've got a high degree of recognition within the marketplace and have won many awards, which we're very proud of. And we continue to go out there and really try to change the landscape within the IoT space. So if you want any more information, email address is there and our website's there. So hopefully you found that useful and found the presentation insightful.
Thank you, Steve.
Not a problem.
Does anyone have any questions?
I have one.
Sure.
Would it be possible to add on a gateway on a lorry or in a container, for instance, where you have lots of returnable, or what do you call them?
Wheel carriers.
Wheel carriers. So that when you do the proof of delivery, you could automate that part a bit, that you can see that all those wheel carriers are on that lorry, and when you deliver, you can see that you have left them at that place, and also when you're going to return them, that you can see where they are located.
You wouldn't need to. You could absolutely. You'd use the tags rather than the gateways. You'd put the gateways at the receiving site and the sending site, because it's an IP-based solution. They will just automatically pick up onto the network within that site. So that's one option, and therefore you can have tags on the devices already. So if you put the tag on the device, the tag will automatically pick up moving forward. So you'd know what left one site, you'd know it had landed and been received into the other site, and you could do the location from that viewpoint. From that viewpoint, absolutely yes, but you wouldn't need to put a gateway onto the truck. What you could do in terms of the tags going forward as well, when we have the Iot deployment, Iot and our solution will coexist, and therefore you could come out of one location. So you're moving away from that mesh. So you know everything that's in that vehicle, and you already know that when that vehicle arrives, you're going to know it's arrived and everything that's in that vehicle, because the IP addresses will pick up onto the new network. But by also using the Iot standard, you could track what's happening in between those two sites as well. So that's one of the reasons around adding Iot to that solution. We do have the capability of, if it was really required, also of adding GPS onto the chips. We don't do that, or we haven't done that on the basis that GPS is exceptionally hungry in terms of power. So we want to keep things sub-gig for the harsh environments and to make sure we're covered there. But there isn't any use case that we couldn't work a deployment for or a solution for based on how we've designed the product. The product has been designed in such a way to give a high degree of complete expandability. But going back to that use case, yes, if you left one site and landed another site, you'd know everything had left and you'd know everything had landed, and you'd know where it was on the site when it went in. So that's one of the beauty of using an open standard IP-based solution.
We got some more questions here. What type
Sure.
of tags are we talking about, and what is the price for these tags compared to EAN?
So the tags are always very difficult when you're comparing prices because you're getting different technologies in the tag. So it's always a comparable. So the tags are around the size of a box of matches. They're IP67 sealed, so they're environmental tag. They're environmentally sealed to be waterproof from that viewpoint. They carry the 6 low-pan radio. They have a gyroscope, a magnetometer in there, and an accelerometer in the base tag. So you'll get movement, orientation, shock, vibration, all of the things that you would need from that standpoint. They also have a 2.4 gig radio, which is in there as well, which we use for commissioning. So, you know, there is BLE in there. We don't use it from that standpoint. And the tags are around $50 for a tag. But the tag, as I say, is quite complex and has quite a lot in it. If there are applications that don't require all of the functionality that is inside the tag, then the tag can be stripped back slightly, and then the cost can be brought down. But actually, our tags are designed at the moment for monitoring what's happening with the assets, as well as locating the asset. Whereas in many instances, most of the other tags are individual separate tags. So you need more than one type of solution. So hopefully that answers that question.
Another question, what do you think of thread technology?
Yeah, I mean, thread is very, very narrow in terms of the data throughputs that you can get on it. I think thread is a good technology, and technology, all technology has its place. But I think in terms of what we're trying to do, thread would be too narrow in terms of the data flow we wanted to actually pull back across. So it has limitations from that standpoint. You know, as do other types of solutions as well.
Another one then. How does Wittra work to secure equipment from digital and physical attacks?
So we have authentication chips on all of our devices, not just on the gateway, which is quite a common approach to take. We actually have the TPM authentication chip within the tag, and also within the routers, and again within the gateway. We actually don't even know what the secure key is when the key comes through. It's that secure. It's one of the reasons why we actually chose Google as a partner initially from a cloud perspective, because of the way that they actually secured the product going forward. So we are as absolutely secure as it's possible to be. You know, we even ourselves, we as I mentioned before, we don't get the keys on the security on those tags. Authentication chips built in at every level.
Very good.
Good. Any other questions? Eller andra frågor? Nej.
Jag tycker det är väldigt spännande. It's very exciting to look at the things that you're doing, and many things on the equipment side is quite good for us, just like Nisse was talking about before. So this is a good combination of melting this together and get everything connected and integrated.
I think if I was to leave kind of a final comment, open standards have to be the way forward. If you look at comments from companies such as Cisco's have said that IoT has a new version, which is open standards. The proprietary solutions aren't going to work, right? Because they are too siloed, and it means that it's very, very difficult to actually have an integrated single visibility and backend solution moving forward. So we're very much about open standards and making it very, very easy to actually deploy. So
Thank you.
thank you.
Thank you, Steve.
Appreciate your time.